everyone, welcome to daily practice. In this video, I will explain you solution of the question that you can see on your screen. So do watch this video till end, and if you find any difficulty, then share it in the comment box or on my Instagram handle that you can see over here. Without wasting any time, let's start the solution of the given question. So solution. First, we will read and understand what we have to actually do. Differentiate with respect to x. So we have to differentiate with respect to x. They have given the function cot inverse of 1 upon x square. So we have to differentiate this function of x with respect to x. Now you can see that this is inverse function of x. So what we will do, we will assume this function of x as y. So let y is equal to cot inverse of 1 upon x square. This is a function of x. So what we have to do, we have assumed this function of x as y, and now we have to convert this function of x into function of y. So how to do that? Let's see. Now here you can see that cot inverse. Now I will take this cot inverse out. So taking cot on both the sides. So after taking cot of both the sides, then what I will get? Cot of y is equal to cot of cot inverse of 1 upon x square. Now this cot and cot inverse will get cancelled. So what I will get? Cot of y is equal to 1 upon x square. Therefore, I will write this as x square is equal to 1 upon cot of y. Therefore, x will be equal to under root of 1 upon cot y will be tan of y. Now here you can see that I have converted the function of x into function of y. This is function of x now, and this is function of y. Now what I will do? Once I have obtained the function of y, I will differentiate the function of y with respect to y and obtain dx by dy. And then by using theorem to find the derivative of inverse function dy by dx, which is 1 upon dx by dy. I will use the value of dx by dy to find the value of derivative of the given function using theorem of derivative of inverse function. So let's see how to do that. Note this as equation number 2. This step as equation number 1. Now I will differentiate equation 2. Differentiate with respect to y. I will differentiate equation 2 with respect to y. So what I will get? Dx by dy is equal to, now this is a composite function. So in this way I will differentiate. Derivative of root tan y will be 1 upon 2 under root of tan y. Now I will multiply this whole term with derivative of tan y. Derivative of tan y is secant square y. So in this way I have obtained the value of dx by dy. So I will further simplify this, and then what I will get? Dx by dy. This under root of tan y is equal to x. So I will put this value over here, 1 upon 2x multiplied by. Now we know the value of secant square y. The value of secant square y is 1 plus tan square y. Now what I will do? I will put the value of tan square y from this equation number 2. So the value of tan square y will be x square will be equal to tan of y. Then tan square will be equal to tan square y will be equal to x raised to 4. So 1 upon 2x inside the bracket 1 plus x raised to 4. Therefore, the value of dx by dy is equal to 1 plus x raised to 4 upon 2x. Now I will use the theorem to calculate the derivative of inverse function. So according to theorem of derivative of inverse function, what I will get, dy by dx is equal to 1 upon dx by dy. Now the value of 1 upon dx by dy is 1 plus x raised to 4 upon 2x. 1 plus x raised to 4 upon 2x. So dy by dx will be equal to this 2x and 1 plus, what I will do, I will write this x raised to 4 as x raised to 2 bracket square. So in this way I have obtained the derivative of cot inverse of 1 upon x square with respect to x. This is our required answer. This is our required answer. Let's see the shortcut method. Now this is cot inverse of 1 upon x square. So I will convert this into tan inverse. So tan inverse of x square. So I have converted this cot inverse of 1 upon x square into tan inverse of x square. This way we have converted the given cot inverse of 1 upon x square into tan inverse of x square. Then this becomes tan inverse of f of x. So this becomes the composite function. So the derivative of tan inverse is 1 upon 1 plus f of x bracket square multiplied by f dash of x. So f dash of x upon 1 plus f of x bracket square. Now here you can see that f of x is x square and f dash of x will be 2x. Now I will substitute these values in this function. So what I will get, f dash of x will be 2x and 1 plus inside the bracket f of x. F of x is x square and its square is x square bracket square. So on simplifying this, what I will get, 2x upon 1 plus x square bracket square. So this is the required answer that we have obtained using this shortcut method or by using the direct formula. I hope you have understood both the methods. If you like the explanation for both the methods, give this video a thumbs up and share it with your friends. And don't forget to subscribe the channel as well as share your doubts in the comment section. See you in the next video. Till then, keep practicing.